molecules, in which they are being made from small organic molecules are joined together to form the macromolecules. Okay. Some of these macromolecules, or most of the macromolecules, they are polymer. Okay, macromolecules are mostly polymer except for one, which I will tell you later. Okay, what it means by polymer is a long molecule where they consist of many similar building blocks. Okay, these similar blocks, the one that they are made of, we call them as monomer. So it is like they have a repeating unit. It is the monomer. Okay, so when you combine the monomers together, you get the polymer. Okay, so out of the 4 classes of organic compounds are polymers: carbohydrates, proteins, and nucleic acids. Lipids are not polymer because they are not being made by similar building blocks. So we will see later in lipid. Okay, so first you must remember this. Polymers, example of polymers are carbohydrates, proteins, and nucleic acids. Okay. I need to click on something, so wait. So I hope you are still all with me. Okay, so we proceed again. So when we want to combine all these different monomer to make the polymer, we call the reaction as condensation reaction or dehydration reaction. So from the word dehydration, meaning is that when you want to join 2 monomers together, you remove the one molecule of water. Okay, or loss of a water molecule. Okay, so this is how you join the monomers together. But when you want to break down the polymers or disassemble the polymer, okay, the reaction is called as hydrolysis. So opposite of dehydration, in hydrolysis, you add water. Okay, so remember the reaction, the 2 different reactions. To join together two monomer, we call that as condensation reaction. Okay, dehydration, you remove water molecules. But when you want to break down them, okay, so we call them as hydrolysis. So here dehydration, remember dehydration reaction. So they will connect. When through dehydration reaction or condensation, like I mentioned, so the molecule is removed, then you can join the monomer to get the polymer. So the opposite, hydrolysis, you add water molecule inside the bone, then you can disassemble or break down the polymer. Okay, so first is water. Before I start, can you tell me how precious is water? How relatable is water to you? Why water is so special? Why water is so useful in your daily life? What is the use of water? Can you tell me? Hello, hello. Why you need water? Can someone tell me why water is so precious? What do you know about water? You drink them every day. What else? Is water only for you to use for showering or drinking? How does it contributes to living organism? Apakah kegunaan air? Is it only for cooking? Can someone domestic use, universal solvent? Are you sure that's all? Oh, someone made a point here. Our body made up to 95% of water. Good. Okay, so Nur Shafika binti Amran. So thank you for that. Okay, so water other than you use for your daily life in cooking, showering or in drinking, how close water is to us is that water, okay, it is not only inside our body, it is also inside our cell. Okay, so where in our cell it is between 70 to 95% of water. Okay, our cell consists of 70 to 95% of water, whereas inside our body itself, we have 65% of water inside your body mass. Okay, your body content. So you must remember that. And inside the water content inside our body, it is important for our body system to maintain a certain volume of water, to retain a certain volume of water inside our body. So we will learn that later. Okay. Other than that, you must also remember, okay, water is also important, not because you use them for cooking, drinking and so on, but there are abundance in earth, and it is actually a place for what type of organism living inside water. They are habitat for aquatic organism. Okay, and the reason why earth is habitable is also because of the abundance of water. Now, this is the chemical structure of water, so you must make sure you can explain the chemical structure of water. So of course, water or H2O, they consist of one oxygen attached to two hydrogen atoms. Okay, but the way how they are attached, normally we can say these molecules, they can attach at a linear, but this one, instead of in a linear, they are attached, the hydrogen are attached to the oxygen at an angle of 104.5 degree. Okay, so the reason here is that they have the covalent bond. Okay, so covalent bond, remember, is the bond that they form through sharing of electron. But the problem with the sharing of electron here is that it is unequal. Okay, they have unequal sharing of electron. So here the oxygen will pull both edge, okay, the electron from each of these hydrogen atom closer to the oxygen itself. Okay, they pull the hydrogen electron more to the oxygen side because they are electronegative. Okay, whereas the hydrogen are partial positive charge. Okay, so it is more towards the oxygen, so that is why instead of linear, they become the H atoms attached to oxygen at an angle of 104.5 degree. Okay, so this is because of the partial charge. So oxygen is partial negative and H is partial positive. So they are not like a charged ions, they only have partial charge. So we call them this as the polar, okay, because they have partial charge. And these water molecules, they are bipolar because they have partial positive from the H and partial negative. Okay, so this is where a certain region is partially negative, and another part of the water molecules is slightly positive. Okay, so that is why they are called as bipolar. Okay, because of the uneven charge from the covalent bond. And other than the covalent bond, okay, one water molecules are attracted to another water molecules because of their partial charge. They can attract other water molecules, so they can bind with other water molecules, in which this partial negative O from this water molecule can be attracted to the partial positive of H from another water molecule. And the opposite lah, the H partial positive H of this water molecule can be attracted to the partial negative from another water molecule. So this bond are what we call as hydrogen bond. Okay, so this hydrogen bond, this one water molecule with another water molecule, they can spontaneously always form the bond and then break, okay, deform the bond, okay, and then they form another bond again. So these hydrogen bonds, they are not as strong as the covalent bond like this one, okay, between O and H inside this water molecule. These hydrogen bonds, they are not strong, but they are just enough to make the water molecules strong, just strong enough to hold the water molecules together. Okay, but they are weaker than the covalent bond. So this makes the water molecule sticky. Okay, meaning they tend to stick with one another lah for the water molecules. Now, there are a few important properties of water. For example, first, like your friend just mentioned just now also, water, one of the unique properties of water is that water is a universal solvent. Okay, so as a universal solvent, this water, they can be a universal solvent for ionic substance. Ionic meaning with the charge, okay? And then some non-ionic substance, meaning polar groups, the one with partial charge, okay? So these two are the type of substance that can dissolve inside water, okay? For example, here we have salt, normal salt. So salt consists of charged ions, okay, which they are consist of sodium chloride. Okay, sodium chlorides are salt. So in the case of this salt, when they are dissolved in water, this sodium chloride, okay, they will become separate from one another. Okay, so the ion and the polar groups will be surrounded by water molecules when they are dissolved in water. Okay, because they are polar, so they tend to attract. Okay, so the partial charge from the water molecule will be attracted to the